One.
Assalamualaikum warahmatullahi wabarakatuh and a very good evening to our lecturer, Dr. Nazri bin Abdul Rahman. So today, me, Muhammad Khalif bin Zainal Abidin and my friend Muhammad Afizul Hasmi bin Hossein will talk about the production of monosodium glutamate MSG for our project Thermodynamic 2. So I will start with what is MSG. MSG is also known as monosodium glutamate, the sodium salt of an alpha amino acid, which is glutamic acid. Like tomatoes and cheese, some food naturally contain monosodium glutamate. For the raw material of this production, different raw materials are made up the monosodium glutamate. Micrococcus glutamisum or Corynebacterium glutamisum is the commonly used bacteria to make monosodium glutamate. For the upstream process, MSG follows the generic bioprocess flow, which is the fermentation process. The high volume of glutamate is kept in the shake flask separately at the beginning of the process. At fermentation, oleic acid is mixed with the mixture at the temperature of 33 degrees Celsius, and the temperature changes involved throughout the process until MSG is produced. In downstream process, unwanted substances are cleared out during extraction, and it took 2 days and 20 degrees Celsius to crystallize the MSG while keeping the product in the storage. For the research problem for this project is manufacturing industry and lighting are used in business that become predominant industrial energy in the production. Each year until 2025, it is expected that industrial energy increased by 1.5%, and currently it is already made up 50% of the global energy. For the research aim of this project, the project aims to increase the quality of the final products and reduce energy consumption throughout the process. And the research objectives are to suggest better equipment to reduce energy consumption throughout the process. Next, to reduce carbon dioxide from the industry. And lastly, to maximize the production by using different raw material. The research scopes of this project is this research was conducted only for a factory that produced MSG, and a little bit description of methodology. A process flow diagram is created, then the process involved in the production area to be studied. And all equipment used will be listed. A spreadsheet program is then created and made to study the mass balance of the entire process and the total energy consumption throughout the process. The spreadsheet program also is used to determine any flaw in the process. Some changes are then applied to improve the quality of the final product and suggest a possible way to improve the production process. After the changes are done, the spreadsheet is once again used to see if there are any changes in energy consumption. So the significance of this study is the study helps to solve mass and energy wastage in the production of MSG. Next, I will pass to my friend to talk more about literature review.
Hello and good evening to Dr. Nazri. So basically, I'm going to explain about the literature review. So for literature review, it's actually a bit of summary of the articles that have been chosen, and then it been combined so that we can relate it all the article to our research project. So basically, there are 3 articles that has been chosen, which is optimization of glutamic acid production by Corynebacterium glutamicum using response surface methodology. The next one would be the bioreactor design via spreadsheet, a study on the monosodium glutamate MSG process. And last is the monosodium glutamate MSG production via fermentation process, modeling and techno-economic assistant TEA using SuperPro Designer. So for the first article, optimization of glutamic acid, basically this article is actually talking about the the importance of raw material to maximize the production of MSG or glutamic acid. So basically, the most important thing in the production of glutamic acid is the carbon sources and the nitrogen sources. So basically, in this article, it talks about three types of carbon uh, sources and three types of nitrogen sources, whereby the carbon sources they use glucose, sucrose, and fructose, while for the nitrogen sources they use urea, uh, ammon- ammonium sulfate, and potassium nitrate. So basically, from the carbon sources, when it is treated with chlorine bacterium glutamicum, it shows that glucose shows the highest or the maximum production of glutamic acid. And when it's treated with the chlorine bacterium glutamicum is treated with the urea, it shows the glutamic acid production also the highest. This means the raw material or the best raw material that can be used is urea and glucose in our carbon, nitrogen sources. So the next one will be the bioreactor design via spreadsheet. Basically, this article talks about the mass balance equation to be formed for the um, our block diagram later. So basically, this articles shows how easy to use Microsoft Excel, as it is one of the software that can we use to create spreadsheet program, and it is much easier to learn and free. So to be compared with other software, uh, Microsoft Excel is much more easier to be used. Other than that, bioreactor design also suggests some of the idea to um, reduce the energy consumption or reduce the cost for the our processes. So the next article is the monosodium glutamate production via fermentation. So basically, this article it talks about four types of processes that can be used to form to produce glutamic acid for the commercial use, but it will much more focus on the fermentation process, and it's much economical compared to the other processes. So basically, other than talking about the processes, it also says that we know that fermentation processes that usually takes too much time or longer time. So basically, they can reduce the time taken by suggesting some modification to the machinery or some of the process, such as for fermentation tank, they can create like a lot more. So that we can reduce the time taken for it to be fermented. So basically, I would say in conclusion, these three articles talks about the how important is the raw material to create, to increase or to maximize the production of MSG. And other than that, it also gives some suggestion how we can reduce the energy consumption of our processes, thus reducing the cost for our processes. So next, I will proceed to our methodology. So for the methodology, the first step is identification of problem. So Muhammad Khalif and I identify what are the problems that had been faced by the factory that produced MSG. So basically, the problem that that had been faced through all the finishing the or final product is first, it is hard to reduce the energy consumption. The next one is CO2 emission. And the last but not least is how they want to maximize the production of MSG. So basically, all this problem has its own solution as for reducing the energy consumption. It's all have or have relationship with the all the machinery, and for the energy consumption, how they want to apply a solution so that the CO2 emission being reduced to the environment. And last but not least, how important is the raw material in maximize the production of MSG. So the next step is literature review. So basically, this literature review, as I've said before, uh, we find article and then combine all the summaries and then related to each of the article to each other. And so that we can know how we can improve uh, our uh, our research project, so that it can be used for another research. And then the next step will be the data collection. In this step, all the data for the mass balance equation, all the data for the energy consumption, CO2 emission are being collected, and then uh, are being collected. So basically, those three articles in the literature review contains all the information for our data collection. So next, I would like to pass the next step for analyzing data to Muhammad Khalif.
Thank you, Hafizul. So the next step in methodology is analyzing the data. So the data that has been collected is interpreted in this section. The data has been calculated and organized in the form of table. The data for energy consumption by old and new machinery in the industry has been compared, and the power consumption has been calculated for 1 month. To analyze the data for the mass, data was collected from article provided with the mass information for the production of MSG. For the industry's CO2 emissions, information was gathered from various articles to compare carbon gas emissions before and after the problem was tackled. Uh, Next step is developing a spreadsheet program where data collected from various sources was calculated in the spreadsheet program. Some calculation was included, such as power consumption, uh, calculation of estimated electricity bill, emission of the greenhouse for carbon dioxide, and lastly, calculating the mass balance. And the last step for the methodology is result and discussion. After the data regarding energy consumption, mass balance, and carbon dioxide emission were collected, a spreadsheet program was developed to calculate and study the energy utilization, raw materials for MSG, and GHG emission of the industry throughout MSG production. The spreadsheet program results were manipulated to help on the recommendation of ways to reduce energy consumption, maximize the production of MSG, and reduce the GHG effects. Besides, all the data were discussed in the section of the study. So next, I will pass to Muhammad Hafizul again to talk about result and discussion.
So firstly is the our block diagram for our mass balance equation. As you guys can see, we only focus on the fermentation tank is because after the fermentation process, all the process actually it's just the same. The mass outlet for this fermentation tank will be to become the mass inlet for the next process, and it will be repeated and again until the finishing. So basically, these are the on discussion for the mass inlet and mass outlet for fermentation tank. As you guys can see, the total mass in is equal to the total mass out for the fermentation tank. This is so I can conclude that the mass in is equal to the mass out for these processes. So next, I will talk about the energy consumption before and after for the fermentation tank processes. No, for the whole processes. So basically, we have the processes for fermentation tank until the packaging. So as you guys can see here, the energy consumption before is much more higher compared to the energy consumption after. I would say the energy consumption before is twice as much as the energy consumption after. So we can see this fermentation tank contributes to the highest power consumption, whereby it's used 300 kilowatt to be operated, while after some modification to the machine or some solution has been selected, we have come to a solution whereby we change the all machinery to new machinery. That's why the new machine has a less power use, which is 100 kilowatt to be operated. Uh, Next, dryer is the most, I would say, contributors to the high energy consumption. This is because it needs more power to heating up the coil in the dryer to be operated. So that's why we choose a dryer whereby it's only use 1.6 kilowatt to be operated in the energy consumption of the. So next will be the result discussion for comparison of energy consumption in 1 month, kilowatt hour. As you guys can see here, the energy before is much more bigger consumption compared to the after. So for the before, it used 270,612 kilowatt hour, and the after is 132,804 kilowatt hour. This means the energy consumption before it's much more higher, thus it cost you a lot of money to pay the electricity bills. So after some modification to the machine, we're using like a new machine, a better, because as you guys know, on all machines, they use like a lot of power to be generated or to be operated. So basically, as years goes by, and engineers already come out with a lot of modification to the machine, so that it use like less power to be operated. This is what we call as efficiency. The same machine using much more less power to be operated as the same power as the older machine. So that's why our energy consumption for machine after is much more lower compared to the before. So next, I would pass it back to Muhammad Khalif to present.
Thank you again, Muhammad Hafizu. So as you can see in the graph, this is the carbon gas emissions comparison before and after updating machines in processes. As you can see, before the carbon gas emission is more than 7,000, and after we can see it is more than 3,000. So as stated as Manjunat et al. 2014, electricity has made it possible for us to do more than what nature and evolution have limited us. So high energy consumption, however, leads the harmful consequences such as high greenhouse gas emissions. The use of energy is one of the sources of high GHG pollution. The second biggest share of greenhouse gas pollution is produced by electricity generated as stated by United States Environmental Agency 2018. The electricity is used by other sectors in household, industry, and factories. It is also possible to relate GHG emissions from the production of electricity to sectors that use electricity. So if we can see the next slide, this is the carbon dioxide emission reduction, where we can see in 2012, the reduction is 31%, and on 2014, the reduction is 26%. So as a new way to produce amino acids, the Ajinomoto community advocate R&D for the implementation of lower resource fermentation technology, reducing carbon dioxide emission and the quantity of sub-raw materials used in amino acid fermentation would help ensure the quality of food supplies and the earth by allowing such more effective use of resources without pollution. So different innovation has been applied increasingly at amino acid processing site since fiscal 2011. So the examples of lower fermentation technology for resources are first, technologies for the internal processing of some of the key materials and the and the efficient use of byproduct as sources of biomass energy. Second, technology to use the tools of non-food as materials. And lastly, to decrease the use of the key sub-raw materials and resources biotechnology. So next, I will pass again to Muhammad Hafizul for discussion part, conclusion part.
Thank you, Muhammad Khalif. So basically, in conclusion, but some recommendation or suggestion has been applied to our problem, which is firstly, how to maximize the uh, production of MSG. The second one would be how to reduce the energy consumption. And lastly, how to reduce the CO2 emission. So basically, for the maximize the production of MSG, it's all about the raw material. The of course, the best raw material produce the best product. So basically, as I stated before, urea and glucose are chosen in our research project so that we can maximize the production of glutamic acid in the production of MSG. So basically, the next step, the next solution for our energy consumption is all the outdated machines are upgraded to less energy consumption machine. This is because an older machine uses a lot much more power to be generate, as I stated before in the result discussion. So that's why all the machine need to be upgraded or changed to a better one, which means a new machine whereby it has the same efficiency but a less power consumption to be operated. So next is for the CO2 emission. The problem can be solved by installing a filter that can reduce the CO2 emission. As we guys know, CO2 emission for industry actually is uh, always kind of bigger to be compared to other machinery that has been used in our houses. So for commercial use, actually, it's much more bigger. So all those, I would say the company should be installing a filter whereby this filter will scrub all the smoke that or the gases that has been released by the machine before it is released to the surrounding, so that the CO2 emission reducing thus reduce also the greenhouse effect. So that's all from our presentation for today. So thank you.